This is the lesson for Chapter 10, Section 6, titled Writing Scientific Notation, day number 2. But I'm also adding in Chapter 10, Section 7, which is Operating in Scientific Notation. So let's take a look at our first problem here, and what it says is that the mass of an atom or molecule is measured in atomic mass units. The atomic mass unit of a carat is 9.3 times 10 to the negative 8th milligram. Is this one here. Find the sum. Okay, so sum means we're going to add numbers together. We're trying to find the sum of the atomic mass units of a carat and a milligram. And we'll write the answer in scientific notation. So we're actually going to use the scientific notation to go ahead and combine these. And the key with combining or adding, subtracting terms is that you have to have place values lined up. So if the exponents are different, that means we need to make them the same. So what I'm going to end up doing is I'm going to take this 1 and 8 tenths times 10 to the negative 7th, and I'm going to change it. I'm going to make this exponent 1 smaller. I'm going to make it a negative 8. And what that does is, in order to do that, to make that 1 smaller, that means that I end up needing to make the multiplier a bigger number, because again, I made this one smaller because I took away 1 from the negative 7 to make negative 8. And that's like dividing by 10. So that means I need to multiply the multiplier by 10 to make it the same number. So I'm going to move the decimal 1 space over. So it's going to be times by 18.0. So now I've got the decimal points lined up because the exponents are the same. And so the multipliers I can go ahead and combine. So this becomes a 3. This becomes a 17. I carry 1 over. I get 27 and 3 tenths times 10 to the negative 8th. So it's not in scientific notation. That's the way we're supposed to write it. So that means I need to move this decimal point to the left 1 space. And so I need to make this one smaller, so I need to make this one bigger. So I need to add 1 exponent to the negative 8. So I end up getting 2 and 73 hundredths times 10 to the negative 7th power. And so that's the atomic mass units. So the other way I could have done that is, which would have probably been a little bit simpler, would have been to go ahead and change the 9 and 3 tenths so it had the same exponent as the negative 7. So I could have added 1 to this, and if I added 1 to the negative 8, that would make this a negative 7. And so if I do that, times 10 to the negative 7th, but if I'm adding a 10 to that, that's like multiplying by 10, I need to divide this number by 10 to make it the same number. So it becomes 0.93. And then I can go ahead and add the 1 and 8 tenths times 10 to the negative 7. So you see how the exponents are the same. And I go ahead and add these together, and I get the same exact answer. 2 and 73 hundredths times 10 to the negative 7th. So that would have been the faster way of doing that problem. Let's take a look at this next one. So it says that this Paleozoic era lasted 5.42 times 10 to the 8 years, and Messianic era lasted this many years. How many more years did this era last than the Messianic era? And so we're supposed to write the answer in scientific notation. So how many more tells me I'm going to end up subtracting the numbers, and so I'm finding out how many more the first era ended up lasting. So I'm going to put that number on top. It's the bigger number anyhow, and see the numbers are in the correct place value because the exponents are the same in this case. So I can go ahead and just subtract the way it's set up. So I go ahead and do the subtraction. I end up needing to borrow when I get to the 10th place, borrow from the 1s, and this ends up making a 2. This makes a 9. So 2 and 91 hundredths times 10 to the 8th years. And so the key is to make sure that the exponents are the same when we're doing this addition or subtraction. And so taking a look at the next problem, it says total power supplied by a jet is this. One set of engines provides this many watts. How much is supplied by the other set of engines? Well, this is the total, so that tells me that it's a subtraction problem. So I'll start off with the 1 and 145 thousandths times 10 to the 8th power. Now again, this is not the same exponent, so I need to make it the same. So I need to add 1 to this to make that the same. That means I'm multiplying this side by 10. That means I need to divide the multiplier by 10 to keep it the same number. So it's going to be a 0.98 times 10 to the 8th power. And so when I go ahead and subtract these numbers, I'll add the extra placeholder there, the 0, so I can see what numbers I'm getting. I have to borrow a little bit, and this becomes a 10, and then I'm ready to do the subtraction. So I end up with a 1, and this makes a 6. So 0.165, 10 to the 8th. And so in this case, I need to go ahead and move that decimal point over to the right one space. That means I'm making it bigger. That means I need to make this one smaller by dividing it by 10. And so I end up with 1 65/100 times 10 to the 7th power. And this is watts was the units in this case. So let's take a look at the next type of problem. It says the diameter of a hair is this, head louse is this, and has the measurement of this in meters, and we're supposed to find the difference in size. Difference tells me I'm going to subtract. So I'm going to subtract the bigger number from the smaller number. So actually the head louse is bigger than the diameter of the hair, because I see that the exponent is closer to 0 since we're dealing with negative numbers. And so I'm going to write down that number, 2 5/10 times 10 to the negative 5th. So in order to, or actually negative 3rd power, so in order to get that exponent the same, I need to add 2 to this. That means I need to divide this by 2. So I need to move this place value over 2 spaces. So it's going to be 0.099. That means I have to add a couple extra zeros there and to get those numbers the same. So I'll go ahead and subtract. And when I do that, I have to borrow all the way from to the 5. That changes to a 4. This first 10 changes to a 9. And so now I'm ready to do the subtraction. So 2.401 times 10 to the negative 3rd power. And so that is in meters. So that's the difference in difference in length, or diameter. And here it says the circumference of the Earth is this. The circumference of Mars is this. Less than Earth's. Okay, so this is this amount less than Earth's. And so we're supposed to find the circumference of Mars in meters. And so if I subtract Earth's circumference from this circumference here, that's going to give me what that value is. And so let's go ahead and set that part up. So I'll go ahead and write down the 4 1/100 times 10 to the 7th. Let's see if the exponents are the same. They sure are. Makes the problem a little bit easier. All I have to do is subtract the multipliers now. So again, the key is to make sure exponents are the same. So I subtract the multipliers. I end up with a 0 to start with. I have to borrow. And I end up with a 2.1 times 10 to the 7th. So there it is, 2 1/10 times 10 to the 7th. That extra 0 is not really needed, so I'll just leave it off. And this is in meters. Let's take a look at the last one. It says an album receives an award if it sells this many copies. The album already sold this many copies. How many more copies does it need to sell? So we're going to subtract again. 1 times 10 to the 7th is how many it needs to sell. They've already sold 9.3 times 10 to the 6th, so we need to make the exponents the same. I need to add 1 to that. That means I need to move this decimal back 1 space. So if I add 1 extra 10, that's like multiplying by 10. That means I need to divide the multiplier by 10 to make the numbers the same. So I'm going to go ahead and erase this 1 and move it over just a bit because I need to add a 0 and underneath that 1 and 0.93 to get that number to be the same as the one I have in the problem initially if I have a power of 7 on the 10. So that means I need to add some extra zeros to the multiplier of the first value and do some borrowing. And so this will be changed to a 9, and so it makes 0.0, and that is 7 times 10 to the 7th. So we need to move that decimal now back 2 spaces to the right to become a 7, and then I need to move this. If I make this one bigger, I need to make this one smaller, so I'm taking away 2 10s, and dividing it by 10, that makes 10 to the 5th. So 7 times 10 to the 5th copies is the answer for this problem. So those are the types of problems that you'll end up seeing on tonight's homework. Good luck.